In this video, we will begin learning about statistics. I have on my screen the handout for chapter 12.1 on sampling, frequency distribution, and graphs. And we'll come right back to this. I just wanted to go over a few vocabulary words that we will cover in statistics. Statistics is a method for collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on data. There are two main areas: descriptive statistics, which is collecting, organizing, summarizing, and presenting data, and inferential statistics, which is making generalizations about and drawing conclusions from the data collected. A population is the set containing all the people or objects whose properties are described and analyzed by the data collector. A sample is a subset or subgroup of that population. And a random sample is a sample that's obtained in a way that every element in the population has an equal chance of being selected. So let's go back to our handout. Suppose a group of hotel owners in Nashville are interested in building casinos in the city. They would like to survey the city's citizens to see how people feel about this. Which of the following methods would be the most appropriate way to select a random sample? A, randomly survey people who live on West End Avenue. B, survey the first 200 names in the phone book. C, randomly select neighborhoods throughout Nashville and then randomly survey people within each neighborhood. D, randomly survey people as they come out of Kroger, Walmart, or Target. The question we must ask ourselves in this problem is, what is the population? Looking at this problem, they are wanting to survey the city's citizens to see how they feel about this casino. So the population in question is the city's citizens. So when we pick the best way to get a random sample, we want to make sure this is representative of the population of the city. So part A is not representative of the entire population because we're only talking about people who live on one street. B, surveying the first 200 names is not a random sample. C would be the best way because we're looking at neighborhoods throughout Nashville and randomly surveying them in each neighborhood. So this is a very good representation of the city citizens. And D was randomly survey people as they come out of these stores. And so you're not really getting everyone because not everybody would shop there. So the best answer for this is C. Now let's go back to our notes. We have various ways of displaying data. We can display data through a frequency distribution or a histogram. And we'll do an example there. We can also display data in a grouped frequency distribution and a stem and leaf plot. So let's begin with the data, and we're going to create a frequency distribution for the data showing final course grades for students in a pre-calculus course. So I brought the information here on my whiteboard, and so the data are final grades from the pre-calculus class, and we have it here. And notice that we have scores from A, B, C, D, and F. So the first thing we're going to do is construct a frequency distribution. So we're going to put all the letters that are represented in the data in one column, and in the second column we're going to list the number of times they appear in our distribution. So the letter A appears 3 times, the letter B appears 5 times, and you want to do this for each of the letters. The sum total of your frequencies is simply adding all of your frequencies up. So the sum is 20. Make sure that matches the number of elements in our data set. So that is a frequency distribution. The next part of this is to draw a histogram. A histogram is a bar graph where the bars touch each other. There are no spaces between the bars. We're going to represent the data on the x-axis and the frequencies on the y-axis. Looking at my frequency distribution, the y-axis should cover the numbers 1 through 9. So I went ahead and put equally spaced marks with a number line from 0 to 9, and then put the letters that are represented in the data. So A has a frequency of 3, so our bar comes up to the 3. B has a frequency of 5. C has a frequency of 9. D has a frequency of 2, and F has a frequency of 1. And you can see that both in the frequency distribution and our histogram, the letter that occurs the most frequent in this data is the letter C. So most students got a C in this pre-calculus class. Going back to the notes, we're going to construct a group frequency distribution for this data here, and then we're going to create a stem and leaf plot. So I copied all these numbers over here to my whiteboard. All right. So the first thing we're going to do is construct a grouped frequency distribution that covers all the numbers from, let's get our lowest number here, and that's the number 41. The highest number is 98. So the groups need to cover all the numbers that's in our data set. So I'm going to group them by tens because it seems like we're going from 40 to about 100. So I'm going to group them in classes from 40 to 49. That will be the first class. And then 50 to 59 will be the second class. And so forth until you get up to 99. The class width is the lower limit minus the lower limit in the previous class. So the class width is 50 minus 40, which is 10. So you can take any two lower limits and subtract them, and you will have the class width. So as I mentioned, the class width is 50 minus 40, which is 10. So you could take any two numbers, lower limits for two consecutive classes, and subtract them, and you will get the class width. You can also take the upper limits and do the same thing. So 59 minus 49 will also give you the class width. So there's lots of ways to find that. So we're going to count all the numbers that are in the first class, 40 through 49. So going back up to my data, I see that there is only one number that's in that range. So the frequency is 1. And if you want, you can keep track by just crossing off the numbers as you go. So I'm going to cross off the 41. Let's find out how many numbers are in the second class from 50 to 59. And so going up to our data, we have 1, 2, 3, 4, 5. So we have 5 numbers that are in the 50 to 59 range. You want to do this for each class and put their frequencies and make sure that the sum of all these frequencies adds up to the number of data that you have in your set. And I've already counted, we have 37 numbers here. So this number matches the sum of all the frequencies. Now we're going to create a stem and leaf plot. So this is another way to organize data. In our stem and leaf plot, we consider the smallest number and the largest number, and then we create our stem from that. So the smallest number is 41. The stem is the number in the tens place. The leaf is the number in the ones place. So the first number is 41. And you can cross it off as you go again, all right? And notice from our frequency distribution, our group frequency distribution, we're going to look for those 5 numbers that are in the 50s range. So it's a stem beginning with 5, and then the numbers are 58. So I'm going to put an 8 for one of the leaves. The next number is 52. So there's my 2, 58, 50, and 57. So we have 8, 0, and 7. So this is representing all of the data that's in our 50 to 59 range. Then the next number is the 60, the numbers in the 60 to 69 range. All right, and you go through. So that is how we create the stem and leaf plot. And you can see that from the group frequency distribution, the numbers that occur most frequent are in the 70 range. And we can also see that in the stem and leaf plot. So what are some of the characteristics here? One of the downsides of a group distribution chart is while you can group these numbers and see the frequencies for each group, we cannot actually see individual data here. We only know that there are 15 scores that are in the 70-79 range. In other words, we lose the actual data when we put it into this distribution. However, in a stem and leaf plot, every single data is included in the information here. So that's the only difference, is that in a group distribution chart, we actually lose data. So let's go back and practice on 12.1 with our frequency distribution. We have an example here that shows the frequency of each data value appears, or the number of times they appear. A college professor surveyed students at the university campus to see how stressed they are, and each student responded by selecting a number from 0 to 10, where 0 is not at all stressed and 10 is extremely stressed. The results are shown below. Construct a frequency distribution. So the first thing we do is look at the lowest number we have and the highest. The lowest is 0, the highest is 10. We create our stress rating here. Remember when we did the grades, we went A, B, C, D, F, right? Here we have 0 through 10. And then we're going to put the frequencies here. So 0 occurs 2 times. Number 1 occurs only once. And again, you could cross these out as you go. All right. And so you're going to put all the frequencies for each number. Now look at the total number we have. We have 1, 2, 3, 4, 5 rows and 10 columns. So we have a total of 50 scores here. So when we add up our frequencies, hopefully you will get the number 50. So the sum of all the frequencies should be 50. And you can check that on your calculator. Question: which stress level describes the most number of students? Well, looking at this data here, it's very difficult to discern that information. But over here on our frequency distribution, we simply look for the highest frequency. Okay. The stress level that has the highest frequency is 7. Do not make the mistake of putting the number 11 when they're asking for stress level. Okay, so be careful when you're answering questions. The next question is how many students reported having that stress level. That's when they're asking for the frequency. So in this case, it's 11 students. In the next problem, the table to the right is a grouped frequency distribution. It groups the data into classes, and I put the number of each class here to the left, and counts the frequency or the number of times the data falls into a particular class. So for example, the table to the right shows data collected by a professor to measure the number of social interactions. He did this by having the students keep a journal, and the students reported the number of interactions to him. Let's find the width of each class. If you recall, we take the lowest limit for each class. So let's take the first two here. 15 minus 5 is equal to 10. We can also take the upper limit. 24 minus 14 equals 10. And that should be consistent for each class. So the class width should be the same for any two consecutive classes. So the class width is 10. The lower limit for the third class is 25. The upper limit for the 8th class is 84. How many students have between 45 and 54 social interactions? So I look in this column, and 45 to 54 social interactions has 11 frequencies. So 11 students had that many social interactions. How many students had at least 65 social interactions? So I'm going to go down this column, and when the question says at least, that is 65 or more. So the number of students who had 65 or more social interactions are 6 plus 6 plus 1 plus 4, which is 17. In 12.2, we start learning about measures of central tendency, such as mean, median, mode, and mid-range. The mean is the sum of the data values divided by the number of values. So if the values are x1, x2, x3, xn, then the mean is found by this formula, x bar, so that's notation for mean. That's equal to x1 plus x2 plus x3 plus plus xn, all over n. Example 1, suppose your test scores for 7 tests were 71, 80, 73, 73, 89, 90, and 97. Find the mean. So we're going to add them all up and divide by the number of scores. All right, and so we could do that on our calculator, right? Just add everything up, hit enter, and then divide by 7. And you get 81.9. I want to show you something. We can also do this on the calculator. So this is kind of a nice handy. We have a program here to find the mean. First, we have to put the numbers in our list. So we start by pressing stat, press enter. And I'm going to my list 1 with my arrow. And I have some numbers here that I want to clear. So I'm going to arrow up to L1, press clear enter, and start typing in your data. Looking at the last data I put in, it says item 7 has a score of 97. that should match the number of scores that you have. And we do have 7 here, so just make sure you check your list that you have all the correct numbers and the number of correct numbers. All right, now we're going to find the mean using a program. Press Stat, arrow to Calc, and then we're going to press Enter, essentially going into the one variable stats program. In this program, they're asking you for the list that you created. We created the list in L1. If you created a different list, L2, you would have to press second and whatever list you were working on. In my case, it was L1. The frequency, there is no frequency list here. We'll come to that in the other problem. And then we're going to calculate. And it's going to give you a lot of data here. All right, so it's given us the mean, the sum of all the x, the standard deviation, the number of items in the list, and then at the bottom we have 5 numbers here. We call the 5-number summary, beginning with our minimum, ending with the maximum. So the smallest number is 71, largest number is 97. The median they give you is 80, and they give you quartiles as well. So that's the 5-number summary. So the mean is indeed 81.9. In example 2, find the mean for the data in the frequency distribution. So here we have scores 1 through 8 and their frequencies. So this means that 1 occurs 2 times. So in order to find the mean, we need to multiply the score by its frequency and add them all up. Then we divide by the total number of frequencies. All right, so the number of frequencies that we have is 2 plus 4 plus 1 plus 3 plus 4 plus 2 plus 3 plus 1, and total of 20. So that's what we're dividing by. Then we work on the sums, 1 times 2 plus 2 times 4 plus 3 times 1, and so forth. Put this on your calculator and you will get 86 in the numerator. And then we divide it by 20. And you should get 4.3. Now I have another way of program. We can use the same program that we did for the last problem, the one variable stats. But this time I'm going to enter 2 lists. I'm going to put the scores as list 1, and I'm going to put the frequencies in list 2. So over on my calculator, press Stat, Calc, Enter. List is going to be let me go back here again because I can't run the program without putting in my list. So I'm going to clear everything off my screen. To clear, we say second mode. Now we're going to edit the list by pressing Stat, Enter. I'm going to clear L1. And to clear, you press Clear, Enter. Enter the numbers 1 through 8. And then we're going to arrow over to L2 and we're going to put in the frequencies. Now we're going to run the program. Press Stat, Calc, Enter, L1. Now we have a frequency list, which is in L2. Press second 2. Calculate, and the mean is 4.3. The median is the middle value of the data. To find the median, the data values must be ordered first. If there's an odd number of values, the median is in the middle. If there is an even number of values, the median is equal to the mean of the 2 middles, the 2 values in the middle. So in the next example, find the median of the two data sets below. In part A, we have the numbers 13, 56, 3, 1, 20, 34, 14, 18, and 29. Let's count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have an odd number here. The first thing we do, according to our instructions, is to order the data, starting with the smallest number, 1, ending in the largest number, which is 56. Now I'm going to put numbers assigned to each of my data, 1 through 9. The middle number is 18. All right, notice it's the fifth number. It's basically half of n plus 1. So n plus 1 is 10, half of that is 5. So we're going to the fifth number. We have 4 numbers to the left and 4 numbers to the right. So the median is 18. In part B, we have an even number of numbers. In this case, we have 10 numbers. We're going to put them in order from 2 to 71. And the middle is actually between the numbers 17 and 23. So we count 1, 2, 3, 4, 5, and 6. So between 5 and 6 is 5.5, right? Another way to find out the middle of the numbers is by adding 1 to n, so that's 11, dividing by 2, so the position is 5.5. Your middle number will be 5.5, which is not a number in the list. So we need to take the two numbers, 17 and 23, add them up and divide by 2. So we're taking the mean of the two middle numbers, and we get 20. I do have a way of getting this on your calculator. If you need a little help putting data in order, we can edit the list, right? So let me start over here. We press Stat and Enter, and I'm going to clear out my lists. And in this list, I have the numbers 13, 56. You can put them in order. I'll show you how to order these in ascending order here in just a moment. All right, so once you have all the data in L1, we're going to order them by pressing Stat, Sort in ascending order. So we scroll down to 2, hit Enter. Here it's asking what list I want to sort. Press second 1, Enter, and it says it's done. So I'm going to go back to the list, press Stat, Enter, and now you can see all the data is in order. So we have a total of 9 numbers, and the middle one is the fifth number, which is 18. So that's really a nice way to order the numbers in a list. Now, as you might have noticed, the position of the mean is n plus 1 over 2. So to find, the median. So the position of the median, we take n, add 1, and then divide by 2. So in the first example, n was 9. So to find the position of the median, 9 plus 1 is 10, 10 divided by 2 is 5. So the median is in the fifth position. The median in part B is n plus 1, which is 11, 11 divided by 2, and that's 5.5. So the position is between 17 and 23, or the fifth and sixth position. So let's go down to example 4. Find the median of the data in the frequency distribution below. 1 has a frequency of 5, 2 has a frequency of 3, and so forth. So what I'm going to do, to find the median, I really want to write down the numbers, the number of times each score appears. So 1 will be written down 5 times, and then we go to 2, and that's written down 3 times, and so forth, okay? Now, before I keep doing this all the way to the last number, since I'm looking for the median, I can pretty much stop at the middle. So what we need to do is find the middle. First, we're going to add up all the frequencies. 5 plus 3 plus 6 plus 6 plus 4 plus 3 plus 2 plus 1. When you do that, you get a total of 30, okay? So to find the median, we add 1 and divide by 2. So 30 plus 1 divided by 2 is 15.5. So we're looking for the number that's between 15 and 16. Obviously, we have an even number of data here, so the actual number won't be here. We're going to have to find the number that's between 15 and 16. All right, so we're going to write down all the numbers. Now, let's see, 1, 1, 1, 2, 3, 4, 5. Let's see where the middle is. 5 plus 3 is 8. 8 plus 6 is 14. So after that number 3, here's the 15th number, and the 4 appears 6 times, right? So we're looking for 15.5, which is after the 4 and before the next 4. Well, the mean of these two numbers is 4. So the median is 4. Now the mode is the number that occurs most often. In example 5, find the mode for each data set below. 3, 1, 8, 7, 11, 8, 4, and 5. Taking a look at all these numbers, the mode is 8 because that number occurs 2 times. And the rest of the numbers only occurs once. In part B, we have 11, 4, 14, 10, 11, 16, 4, and 1. Here, the numbers 11 and 4 occurs twice. So we have 2 numbers that represent the mode. So we could say this is bimodal. In part C, 7, 1, 4, 10, 13, 2, and 5, there's not one number that appears more than once, so there is no mode here. The mid-range is found by adding the lowest and highest data values and then dividing the sum by 2. So here's the formula. Let's find the mid-range of the data set number 6. 34, 76, 19, all these numbers, right? So we're looking for the lowest data, and I'm going to underline that. This is 14. The highest data value is 80. We're going to add those numbers up and then divide by 2. And we get 47. So the mid-range of this data is 47. Find the mid-range of the data in the frequency distribution below. All right, so we have scores from 70 to 77. And in our formula, we need the lowest score, which is 70, and the highest score, which is 77. And we're going to add those two numbers up and then divide by 2, and we get 73.5. Example 8, use the display of data to find the mean, median, mode, and mid-range. So now we have a line graph, and we have the frequencies on the left and the scores on the bottom here. And the scores begin with 10. 10 has a frequency of 2. 11 has a frequency of 2. So to find the total number of frequencies, we add up 2 plus 2 plus 5 plus 6 plus 1 plus 2. So we have a total of 18. To find the mean, we take the score, which is 10, and multiply by its frequency. So 10 times 2 plus 11 times 2 plus 12 times 5 plus 13 times 6 plus 14 times 1 plus 15 times 2. I can do this with you on the calculator. Now we get the numerator first, which is 224, and then we're going to divide by 18, and we get 12.44. So the mean is 12.44, or 12.4 repeating. The median, to find the median, we first find out which number is going to be in the middle of the data. Now notice we have an even number of data here. So to find the median, we're looking at n plus 1 over 2, which is the 9.5 position. So we're going to write down all my scores. So 10 occurs twice, so we have 2 10s, we have 2 11s, and then we have 5 12s, and then we have 3 13s, and so forth. And once you feel like you've got at least 9 or 10 numbers, you can stop and count 1 2 3 4 5 6 7 8 9, and here's 10. So the score is between 12 and 13, which comes to 12.5. So the median is 12.5. The mode is the number that occurs the most, and we can see that in our chart that 13 occurs most frequently, 6 times. All right, so the mode is 13. Remember, the mode is always the score, not the frequency, okay? The mid-range is the smallest number plus the largest number. So the smallest number is 10, the largest number is 15. Add those up, which is 25, divide by 2, and we get 12.5. And that is it for 12.2. We're going to end this video, and the next one we will cover 12.3. Have a good day.